Thank you, Meg. And again, welcome everyone, and thanks for your time. I know it's late in the afternoon. I'm going to keep this quite simple, and I'm not going to be quite as colourful as Terry, our poster boy. So yeah, we'll get right into it. So I guess just very briefly, I'm just going to run through some of the key highlights of Program 4, and we've got a really interesting session planned for Program 4 this afternoon. I'm hoping it'll be quite interesting for everybody. So I guess a couple of the key highlights are we've got 15 grower groups working across Program 4, across a whole host of projects in Program 4. That's a great outcome. We've got most of the universities in the CRC are contributing. We've got industry partners, and we've got 3 government research organisations working towards the final outcome of Program 4. So Program 4 is focused on integrated solutions. This is where we're bringing together some of the technologies, ideas, latest thinking around cover cropping and subsoil amelioration, some of the latest ideas around monitoring soil moisture, for example, bringing that together, applying them in the field, and using that data that we're generating to deliver some models. And we're going to hear from Keith and Chloe later on some of the highlights of that particular work. I'd like to point out that I think where Program 4 is really heading towards now, and we had a nice session there yesterday where we combined some of the outcomes of Program 1 with Program 4, and we had some joint program discussion. And I think really we're starting to focus on that at pointy end of adoption. How do we get some of our thinking and our ideas on the ground? And one example of that is the project that Mick Rose wrapped up in June this year. So that was the work on herbicide residues causing phytotoxicity to following crops, and some of the models, some of the Bayesian models that are associated with that. So the CRC can conduct research, but I don't know if we're necessarily a commercialisation organisation. So the good thing is some of the IP from that project now is going forward with a GRDC multi-party project around sort of geospatial understanding of herbicide residues. And I think that's a really good mechanism to take our IP from the CRC forward. And yeah, that's quite an exciting, very large project, and probably beyond the scope of what we or what our partners could actually deliver. So I think that's a great adoption pathway. We've got 9 PhD students. I'm very excited with our PhD students. We're going to hear 3 PhD students very soon. Hanlu, David and Cam, so I'm not going to speak about what they're talking about. We've got some other PhD students. Stephen Lang has recently, or moderately recently joined. He's going to be focused on subsoil constraints, in particular on calcareous soils and root penetration and soil physics. And not a lot of soil physicists around anymore, so it's great that you're working in that area. VJ is developing some very unique methods for looking at residual herbicides in soil and potentially linking that to some of Mick's outputs around toxicity. Suman from USQ is working on reverse modelling within APSIM, and I think Keith and Chloe might be showing some of that data or utilising some of that data. So some really clever stuff happening there. Win-Win at Murdoch, again associated with Mick's herbicide project, is working almost wrapped up now, but understanding again some of the herbicide issues in sandy soils and what that means to quite a range of crops. Navita, who is working at Newcastle Uni under Ravi, is doing some really interesting stuff on non-wetting soils. So she's actually taking some of the gut microflora from koalas, some of the enzymes from koalas, and seeing how they break down some of the oils and waxes that are causing some of the non-wetting issues in the non-wetting sands. So yeah, there's some really novel, interesting, different approaches being used. And Cameron, who I'm attending her confirmation of candidature up at Griffith University on Friday, is doing some really great work around resilience. And if we ameliorate soils, if we ameliorate subsoil constraints, does that make those soils more resistant and more resilient? So yeah, there's some great outcomes there. But just in a nutshell, you've probably most of you have seen this before. The Program 4 has got 3 key output areas. One is around the plant-based systems. And, again, our poster boy has been leading most of the work on that with regards to cover crops and intercrops. And, we've got a few projects going, and we've had additional co-investment in some of these projects. So that's great. And even better is, couple of those sites will be carried forward in the future drought fund. So, Michael mentioned this morning that CRC's attracted an extra $3.9 odd million. I think we've got 8 or 9 field trials within that project, and I really need to acknowledge Luca Di Prato and Richard Bell for that. They put in a momentous effort getting that application into the feds. So thank you for that, and I think that's a great way, another great legacy for some of the outcomes from Program 4 and the CRC more broadly, is that that's going to outlive the CRC. So we've got some of our field sites carrying forward. So how good is that? Within that, some of the key outcomes are, what do we understand about cover crops? What are the risks of cover crops? And Terry and I have spent a lot of time chatting about this, pontificating, as he will call it. And some of the issues are around water use. So a lot of the studies are from overseas that go cover crops are fantastic. Let's pump in as much carbon into the soil, but they use water. So what happens in rain-limited systems? In sites with less than 400 mils of rain, are they going to take up the water that's needed by the cash crop? What are the consequences? What are the benefits? And Alice Melland is also contributing to some of that thinking with Hanlu around the modelling component of water usage, around understanding how much water these cover crops actually use, how much they leave in the soil, where the water's left in the soil. And I think one of the sites at that Stinking Goat, I haven't seen it in person, but I understand it looks like it's on intensive care. I think there's 100 odd soil moisture probes at that site, or 80 or something like that. So it's a massively invested site, and I think there's going to be a lot of great information coming out of that. Another aspect of Output 1 is some of the work around regenerative agriculture. I've been working, most of you might have heard Gwen talk last year around her project. The final report, I think, is being finalised right now, and hopefully that will be available for everyone very, very soon. Some interesting findings in there. And I guess the other key aspect is this term resistance and resilience. So there's a lot of people talking about, I want to build up the resilience of my soil, but what does it actually mean? So work that's being done by Mayran Rashdi and his project team are actually developing metrics around trying to understand what a resistant soil is. So when you start imparting a stress onto a soil, it might be drought, it might be compaction. How long can that soil continue to function with that stress being imposed? And then you have a resilience factor as well, which is some metrics being assessed for that. So, okay, the system's crashed, run out of water, it's not cycling nitrogen anymore, it's not respiring. How long does it take for that soil to get back up to where it was prior to that major stress factor? So there's some really interesting work being done there. Output 2, we've got a whole stack of field trials in Output 2. I think we've moved sort of beyond the lab studies now, and these are where we're really focusing on some of the field trials. And we had an interesting meeting with the grower groups this morning, and one of the restrictions to adoption, I guess, we do farm walks. 1 minute, thank you. I think I should be done in 1 minute. One of the restrictions to farm walks is adoption. Growers see what's happening in a small plot, and they go, small plots aren't going to work at my place. So I think the guys in WA have addressed this to an extent, and I think the computer's crashed. That's all right. These are our small plots now. We've got massive paddock scale trials happening in WA, and we've moved well and truly beyond the small plot studies. Understanding what happens, this is a bed in the system, where they're actually delving into a sandy soil, pretty bleached A horizon, bringing up some clay from depth, getting some of the organic matter from the surface, dropping down into that sort of B horizon, mixing the soil up a little bit, improving its non-wettability. We're getting some definite improvements in crop growth at some of these trial sites, and I think they're starting to understand the mechanisms for that. We've got some novel amendments going into the field sites. I speak to Hassan around some of those novel amendments. We've got the Calcareous Soil Project, which is delivering some great outcomes. And what's important too is that a lot of these field sites aren't in isolation now. They're actually working across different programs and different projects. So, we saw a mixed project before in the biological indicators, utilising some of the field sites from Program 4. So I think, we've got some great collaboration, great interaction happening. That's it for Program 4 update. You don't want to hear too much more from me because I think there's some much more interesting stuff